talking about derivatives and what they are, what they do. So, two things you should know before going into this video are limits and slope lines. You should know how to find the slope of 2 points. Whoa. I don't know, I forgot what I was talking about. Basically, hopefully you know how to find the slope with 2 points. Oh my goodness. Okay. So you have y, right? Why are they barking? I don't know. I don't know. This is how you find the slope with two lines, right? I mean 2 points, right? If I had a slope, right? This point, right? I plug in the numbers, I get a line that goes through them. That's a slope line, right? It's our rate of change between these 2 points. How do we find the rate of change at one point? Well, that's what derivative lets us do. So, and this is the operation symbol for a derivative, right? You have multiplication symbol, division symbol, addition symbol, subtraction symbol. This is the derivative symbol. And let's say our line was this x squared, right? Hopefully you know how to plot lines and how to graph an x squared, like you know at least what it looks like. And the derivative for this would be 2x. I'll show in a moment how to do it the long way, and the is normally how you get introduced with derivatives in your calculus 1 class. But I'm just going to tell you the answer right here is 2x, and this is the what I'm going to be doing the long way. This is the example I'm going to use for the long way that I'll show you how to do it. So it's 2x, and now when I plug in numbers in this function, it'll give me the slope line at any point at that x point. So if I had, I don't know, at point with the next value of 3, right? I'll just plug in 3 for this, and it'll give me the slope. Right, this gives us our m value for with 2 points. This gives us our m value for at a single point. So it'd be, 6, which is our m value, right? This is our slope for a single point. Just gonna draw a quick little graph right now to illustrate what I'm talking about. Okay. Y equals x squared, and I'm also gonna write it this way. This is the exact same thing. I just replaced the y with a function symbol, and they're basically the same thing. Quite literally the same thing. Anyways, so the graph for that kind of looks like, kind of, don't worry about this side. We're just gonna focus on this side. It kind of looks like this, not exactly, but it doesn't matter for illustration purposes. So if we had a point up here and a point down there, and a point up here, we do this thing, right? And then we get our ruler here, and then whatever that slope is, it's gonna look something like this. It's gonna be a line that goes through both points. So if I can line this up, right? We call this a secant line because it goes through 2 points. And this is the slope for these 2 points, right? So this is the slope line, which is our rate of change between these 2 points. Now, we're going to call this point x, right? Because it's some x value, right? This is our x line, right? And this is our y line. So we're just going to call it x. And we're going to call this point x plus h, this point up here. Because the distance between the right, this is the distance between this point and this point. The distance between them is h. So I just did x plus h, right? Because if we just added h distance, we would get to this point, right? The x value distance, right? And now the whole concept, I'm going to write the limit definition out here on the side. This is an h. So this is the limit definition for a derivative. This is how you would do it the long way. So we don't want 2 points, we just want 1 point. We just want to work with 1 point. But it's really easy to find the slope of 2 points, right? You just do the formula, this formula right here, right? You just do that and you get your slope. So we want to do this in a similar way. And this is just this in disguise. It's really just the same thing. I might go in a deeper dive into derivatives in the future, but for now, all you need to know is that this is just secretly this guy over here. And our h is on the bottom because our distance is x, right? This is our distance x, right? Because this is our x line. Our distances in x go on the bottom, right? And our h, I'm just substituting our x for h over here. And our y values, right? Right, I just replaced y with fx, right? So this is a way you can look at it, right? Instead of y, I used fx's, right? I just replaced the y with the f of x. And essentially, we're going to take both these points, we're going to move them really close to each other, an infinite amount of closeness, basically. I just pick a random point here. We're going to put them so close together that this distance is going to get smaller and smaller. The h distance is going to get smaller and smaller until the distance, it's basically 0. So that's why there's a limit symbol. So we just want to squeeze these points so close to each other that we're going to get basically the distance is 0. Which is why we have h approaching 0. The distance is approaching 0 between the 2 points. Now I'm going to do the example right down here. For f of x, so for x squared. So we're going to write limit h approaching 0, and then hopefully you know how to do this already. This is an algebra concept that I'll talk about one day. But you just need to know how to plug in where to plug in stuff, right? And we're just going to put h down here. So all I did is replace this guy for all this stuff over here, right? Hopefully you know how to do that, at least if you're watching this video. And then we need to take the limit of this, but we can't take the limit currently because the bottom is like, if we just what we want to do is just plug in 0 for h, but we can't do that right now because our h is on the bottom and we can't divide by 0. So first I'm just gonna FOIL this guy out, which is gonna be, I'm just gonna write it down here. You can do the work on the side, but this is what it should be. So I just squared everything and I got this, right? And if you notice, this is a minus x squared and this is a plus x squared, so I could just cross those out, right? They cancel out. It's just 0. X squared minus x squared. It's just 0. And we're just left with this stuff on the top. And then we're going to, one more time, we're going to, actually second to last time, we're going to rewrite it down here. And we're going to divide everything by h. Whatever remains, we're going to divide that by h. And we're going to be left with, this just becomes 1, by the way. You should know that. 2x h divided by h plus h squared divided by h, right? And hopefully you should know that these two cancel out. This is just h, right? And what we're left with, I'm just going to write it over here because we got some space up here. So all I'm left with is the limit of h approaching 0 with 2x plus h, right? And now, because I don't have anything dividing by 0, I could just plug in 0 for h. So it'd be 2x plus 0, which is 2x, right? I remember in the beginning of the video, I said that the derivative of x squared is just 2x, right? So this is the same thing, right? I just did it the really long way. But yeah, that's what a derivative is. We're basically finding the slope like how we would normally do it, when you're learning it in algebra, but we're using limits because we're going to make the distance between the 2 points so close that it's practically zero. We're just squeezing the points infinitely close to each other that it's zero, which is basically just at a single point, right? The distance from one point, like if I said the distance, what's the distance between this point and the same point? Well, the distance is zero because you're already there, right? So that's why it's like a singular point. That's why we're putting it so close to each other that it's zero, so it can just basically just be at one point. Hopefully that wasn't too confusing. But yeah, all you really need to know to understand derivatives in the beginning is that we're taking 2 points, moving them really close to each other so the distance between the 2 points is zero, and then boom, that's our derivative function. And I'll make videos on the rules for doing derivatives, which allow us to not have to do all this work to get to the same answer, right? And I'll make a video on those later. So yeah, that's about it for now.